Hello everyone, my name is Atul Kumar Singh. Today we are going to solve LeetCode problem number 162, that is find peak element. So a peak element is an element that is strictly greater than its neighbor. Means we are given a array of integers and we have to find peak elements. A peak element is a number which is greater than the element which is in its left side and also which is in its right side. For example, if we take 1 have nothing in left side, so we have to check for the right side. So if we check for the right side, 1 is not greater than 2. So it can't be our peak element. Then we will check for 2. 2 we have to check for the neighboring element, that is left and right. If we check the neighbor 1, 2 is greater. If we check the neighbor right, 3, compare with 3, 2 is small. So 2 can't be our peak element. So if we compare 3, so if we check for 3 and compare with 2, the neighbor 2, 3 is greater. And compare with neighbor 1, then also 3 is greater. So in this case, 3 is our peak element. We have to return the index of the peak element. So on observing what we can see, we can observe some edge cases. What happens if the array contains only one element? Then the zeroth index will be our peak element. Means the single number despite of anything will be our peak element. What happens if the zeroth index or the last index is our peak element? What happens if the zeroth index and the last index is our peak element? So for zeroth index we can't check the left, so we have to check for the right. So for zeroth index we'll only check for the right, and for the last index we'll only check for the left. And despite of all the despite of all it, for example, the zeroth index, the last element, remaining all elements we will check for both the left and the right. So now let's code and check it. We will use binary search to do this. So we'll first get the length of the nums, and then equal to nums dot size, and then equal to nums dot size. Okay. What happens if it has only one element? Then simply the zeroth index will be our answer. What happens if the zeroth index or the last index is our peak element? Then for zeroth index there is no left, and for the right index there is no right. So for the zeroth index we will only check for the right, and for the last index we will only check for the left. So if nums of 0 is greater than nums of 1, means our for zeroth index there is no left, so we will only check for the right. If it's greater, then we can say zeroth index is the peak element. So now let's handle the another edge case, that if last index is our peak element. So if nums of n minus 1 is greater than nums of n minus 2, means if the last element is greater than the second last element, then we can say the last element is our peak element, because there is no right for the last element. Right? Now, when if we will do from low, we will take 1, as we have already handled for the zero case, and for high, we will check n minus 2. So between this range, we can check for both left and right. And for the zeroth index and the last index, we can't check both left and right. So we have handled the edge cases above. So now between this range, if our answer lies, we use the boundary search. While low is less than equal to high, then this loop will run, and for every we will calculate the mid. Mid equal to low plus high, low plus high divided by 2. And if we found if mid the index we get is greater than the left side and also greater than the right side, then our mid is the answer. If it is a array name nums of mid is greater than the left side, nums of mid plus 1, and also along with it, it's also greater than the right side. What a peak element says, the number should be greater than the left and the right side used in every element. So nums of mid, it's greater than the right side. Now let's check for this if it's greater than the left side or not. If it's greater than the left side also, then we'll can simply return the mid. Else any of the cases happen, it's it's only greater than nums of mid plus 1. If we can say nums of mid is greater than nums of mid minus 1. Means if it's greater than the left side, means there is an increasing slope. And this is your nums of mid. And nums of mid is greater than the previous its neighboring element. It's an increasing curve. So we can say left can't be the answer, right can be my answer. So we will remove the left subspace and we will include the right subspace because it is an increasing curve. So we'll remove the left subspace, and if the opposite of this happens, then we can simply do phi equal to mid minus 1. And at last, we will return our minus 1 is not found anything. If this is satisfied, then we'll return the mid. These are the all edge cases handled. Now let's try to run and check for the two test cases given. So we are getting a compiler on line number 25 with a missing semicolon and nums of mid is greater than nums of the sorry mid. So now let's try to run it. Again we are getting it. It takes symmetry rather than description. So while we are encountering this, let's check. Sorry, else if we have to do we have done it else. So I don't think it's to check this. Now let's compile it. Check for the test cases. Two test cases are passed successfully. Now let's submit the code. So it's giving wrong answer for input 1 2. Output we are getting minus 1. Now we are getting this. We have taken low h1, high h and minus 2. Now low is less than or equal to high. Mid is low plus high divided by 2. Okay. If minus 1 comma 2, then if minus 1 comma 2, output is minus 1 and expected is 1. Oh yes, expected is 1. Then so yeah, when elements 2 is the peak element, 0 and 1. So it should lie under this weight basis, nums of n minus 1 is greater than nums of n minus 2. This is here. We have handled the test case wrong. Now let's submit. Let's check it's passing. Yeah, it's passed all the test cases. Now let's discuss the space and time complexity. What is the time complexity? If you are using binary search, setting the search space again and again, time complexity is big of login, and we are not using any extra space, so space complexity is big of 1. So that's all about this question. Thanks for watching this video.